Okay, this is part 2 of my little series on how to use molar mass. So we have just learned in our last lesson that the molar mass can be calculated as long as we know the chemical formula for the substance. For example, let's say we had some water. I'm going to start with a nice and easy one. And I know that that water is, say, dihydrogen monoxide, which means I can get the formula, H2O. And knowing our technique, we can use our periodic table to calculate the molar mass. And as I stated in the last episode, I guess, if that's what I'm doing, we have new units and we need to think of it, and we need to think of it very forcefully. Grams per mole. All right. So now we want to generate an equation that allows us to calculate grams and moles using this molar mass. Because whenever you have a unit that is made up of 2 units as a fraction like that, you can use that number as almost like a conversion number. It allows you to find grams or moles of that particular substance. So we need to come up with an equation. So let's think about the unit. That's going to get us our equation. Let's write down this 18 one more time, just down here, grams per mole. All right? Now look at that unit. It's got 2 parts to it. It's got the top part, which is grams. That's a mass. And so the symbol we like to use for mass is small m. So when we're talking about calculating mass or grams, we like small m. Take a look at the unit on the bottom. That says moles. We've encountered moles. We encountered moles in the last equation that we used, which is on entities, an Avogadro's number, and moles. And remember, moles was a little n because it tends to be a small number, where entities is a big N. So take a look at the way those 2 things are positioned. The mass number is above the moles number. That's going to guide us in our equation. If we have mass and we divide it by moles, just like that in the unit, then we have, well, the molar mass. And we used 2 m's to represent the molar mass in the last lesson. There it is. We've created the equation that allows us to figure out mass or moles if I know the molar mass. So now that we've got it written out, we can kind of reverse engineer it. Mass is in grams. We took that straight from the unit. Notice the unit is where we started. If you know the unit, you can always make the formula for the molar mass. N, well, that's the moles. That's what we got it from, the unit. And mm is the molar mass, which we get from the formula along with the periodic table. So if we know the formula and we know what substance it is, then we know the molar mass. Okay, we've got our periodic table. We know how to get chemical formulas, I hope, and we know what grams are and we know what moles are. If we're not a fan of rearranging equations, we can put this in a triangle, just like we did the last one. I don't know if you recall the way you build a triangle. If I have a fraction as one of the sides, and I do right here, then the thing that's on the top of the fraction goes on the top of the triangle. So in this case, mass is on the top, moles and molar mass. All right. We multiply the 2 on the bottom, and we divide anything that's above or below. Okay. Let's do some examples. Find the number of moles in 56.8 grams of magnesium hydroxide. Now, I am going to show you a little technique that I like to use when doing calculations like this, because as we continue on and do more complicated questions, sometimes it's useful to have a map that guides us in our thoughts. So when the question asks, find the number of moles, and I'm given grams in mass, I will quickly write down the fact that I'm starting with a mass and that I want to find moles. And whenever I have mass and I want to find moles, I need that number that links mass and moles, and that number is the molar mass. All right? Which means we need our equation that we just determined moments ago. Mass is in M, moles is N, and molar mass we get from our periodic table. So whenever we have a map like this that I just drew, and molar mass is one of the things we're looking for, the first thing I do is I write off to the right side of my page, and I just like to do it that way. It's just the way I've always done it. The formula that we need: magnesium hydroxide. Magnesium is 2, hydroxide is 1, and we get the molar mass. Very often the molar mass is one of the first things that we need, and we need to be able to do it quickly and efficiently. So we have our periodic table. It should always be out. Really, from here on to the end of the course, you should have your periodic table out at the beginning of the lesson, and we proceed to get the molar mass. Again, pause. See if you can do the molar mass before me. And then play. See if you get it right. I got to check what a magnesium is. Again, when you're done writing the molar mass, grams per mole, like a chemistry zombie. So, I want to get moles. It wouldn't even hurt to write your triangle underneath it. Remember, grams per mole. Mass over moles is molar mass. Again, that triangle builds itself from the unit. Grams on top, mass on top, moles on the bottom. I want to get moles. Remember, I cover up what I want to get. N is equal to mass over the molar mass. And it's that simple. .8 grams divided by 58.3 grams per mole. I'm not going to show you my fancy calculator because we don't need it at this point. I'm not doing scientific notation. 56.8 divided by 58.3 equals 3 significant digits, 0.974, and my units are moles. Again, I do suggest you always write down what you calculated it for along with it. All right? Okay? Okay. Pretty straightforward business. Find the number of moles. Put it at the end of my map. Starting with grams. Put it at the beginning of my map. Mass to moles is always a molar mass. We get the molar mass, build our equation, and go. This example is exactly the same as the last example. If I was doing this in class, I would run through it, but I'm going to go on to the next one. Wait a minute, it's not the same. Back up. I want to find the mass of that many moles. This is opposite. I do need to do this one. So let's look at this. Thought it was the same, but it's not. I want to find the mass. The mass is going to be at the end of my map. Again, pause it so you can write the question down. I'm starting with moles. To convert mass to moles, I need a molar mass. Moles is N, mass is M. As soon as I know that I need a molar mass, I'm going to start figuring out the formula. Sodium is 1 and sulfate is 2. And I've always got to check sulfur. I always forget. 32.1. And sodium isn't one I don't use often. 23.0. Again, pause so that you can calculate. Make sure you're getting the right answers. $142.1. Sorry, yeah, 142.1. Grams per mole, unit, super important. Grams per mole, mass, moles, molar mass. I want to find the mass. I cover up the M. M equals molar mass times moles. 142.1 grams per mole times 1.45 moles. I still have the 142.1 in my calculator. 1.45. 206. And it looks like 3 significant digits right there. That's 1, 2, 3 significant digits. So that's enough there. This is a unit of mass. It is grams. Again, I always suggest you write down what the stuff is that you just calculated for sodium sulfate. Okay. That's how you go the other way. This question is special because notice that I've got a prefix in front of it, kilo. Don't mind that bell. So, what do we do when we have a kilo in front of it? There's 2 ways to deal with it. We can change the kilo by using the power of 10 that kilo is worth and putting it in front of it. Okay? So let's just take a look at that. 16.0 kilograms. Now again, on your chart, and I've got my periodic table. You can hear me. I'm crinkling it. And I'm looking at that page, which I call the back. Look at it. You should have it right there in front of you. In the main box under the chemistry data sheet title, you will see on the right-hand side a bunch of metric prefixes. Giga, mega, kilo, centi, milli, micro, nano. And you can see that kilo stands for times 10 to the 3. The easiest way to fix this is to simply write this as 16 times 10 to the 3 grams, because we need the unit to be in grams. Now, you could leave the kilo. In the end, if you leave the kilo, we wouldn't get moles, but we would get kilomoles. So you could do the entire calculation keeping the kilo in there. And in the end, you would just get a unit of moles that has kilos in front of it. 10 to the 3. I really don't care what method you use. We've already converted the 16 kilograms into grams, so I'm going to continue that way. So again, let's now proceed with the question. And you do not have to write it out like I just did here. I'm just explaining to you how you can deal with it. Okay, find the number of moles. I'm going to make my math. That's where I want to end up. I'm starting with a mass. We know that to convert a mass to moles, you need the molar mass from our periodic table, and therefore we need a formula. Calcium is 2 and carbonate is 2. So the 2 and the 2 cancel out. Again, pause. I maybe did that a little fast, but try to get ahead of me. I have 100.1 grams per mole. Again, I build my triangle using that unit. What goes on the top? Grams. That's an M. Moles on the bottom. That's my molar mass. Find the number of moles. I cover up the N. I've converted the mass. 16.0 times 10 to the 3 grams divided by the molar mass. 100.1 grams per mole. Again, if I had left the kilo, my answer in the end would be kilomoles. I'm not going to show you my calculator, but I'm now going to press the EE or EXP button. 3 divided by 100.1 equals 159.8. It's looking like it's 160 moles. Right, on my calculator I had 159.84. I'm rounding that to 1, 2, 3 digits. All right. One more. This is my last one of this little section, and then I've got a couple more examples where we're going to put our two equations together. I'll make a separate video. Ignore the bell. Notice in this one I have millimoles. Again, I could go to my chart and I could find what milli means. But I'm going to leave the milli this time. Find the mass of. My setup is always the same. I'm starting with moles. Technically, I'm starting with millimoles, but that's okay. The milli just means a tiny number, 10 to the negative 3. I need a molar mass. Nice, this is water. Whoops, that is not the formula of water. Now, water is one of those substances that we are going to see over and over again, and you might already know the molar mass of water. If you do, you can just write it straight down. 16 plus 2. It's always 18 grams per mole. Grams, mass on the top, moles, molar mass. In this case, I want to find the mass. I cover the mass up. Mass equals molar mass times moles. Molar mass, 18.0 grams per mole times 2.00 millimole. Now, technically, what happens in the calculation is that the mole cancels out the mole in the molar mass unit. But notice that my prefix milli is still there, which means the units that I have at the end are milligrams. So the milli hangs around. There is nothing wrong with that calculation, and I should be able to do that in my head. What have I got? 36.0 milligrams of H2O. So you can leave the prefixes unless I ask you specifically to calculate the mass in grams. But notice it just says find the mass. It doesn't say find the mass in grams. and that is technically a good mass. All right, so you can do a few more questions that deal with the molar mass, and I am going to stop, and then I'm going to make one more video that deals with entities, where we're going to use two equations.